Hi, I wanted to introduce to you Worksheet 2B. In the past, students have had a lot of trouble with this worksheet, and it's really because they don't quite understand how they're supposed to format their answers. So, and to emphasize that, really, there's a rubric when you look at your assignment, and at the time of this recording, at least, and I'm sure it'll stay the same, the formatting of how you solve the problem, okay, is 60% of the worksheet's value. 20% is given to um, the actual answer, and 20% is for following what we call significant figures, right? Keeping track of precision correctly. So that's the thing I really wanted to emphasize this semester. Do the worksheet the way it was intended to be done. This is the same kind of calculations that we'll be doing all throughout the semester using chemical quantities rather than things like ounces or grams or velocities like meters per second. We'll be doing it with chemical quantities later in the semester. And it's really important that you get the hang of how to work these problems out. So let's go down and talk a little bit about equivalent relationships. In this particular passage, it's actually like a story problem, and it's helping you to break down the story problem. And this is a strategy, and this is one of the things in the worksheet. In this strategy, what we come up with is equivalent relationships. So for example here, one candy bar equals 45 cents. That comes from the statement, one candy bar requires 45 cents to purchase. Now, we know a candy bar and 45 cents aren't the same. Like, I can't give you 9 nickels and you eat them and you go, that was a delicious candy bar, right? You can't actually do that. So that's why we say these are equivalent relationships. It's not that they are that thing, but they're the equivalent value of that thing, okay? So then, given equivalency statements or equivalent relationships, you can write what are called conversion factors. So for example, for 100 cents is equal to $1, that's something you know from just like information in your head, right? You can write a statement that looks like this or this. And what does that actually say? Well, the first one, let's call this 1 and let's call this 2, right? The first one, statement number 1, says there's 100 cents per dollar, right? The line means per. But you could also say the statement another way. There's $1 per 100 cents. Both of those are true relationships, correct? Right? You know that it doesn't matter how you say it, you don't really alter anything when you say that. So if you have $2, for example, how many cents is that? Well, intuitively, you know that's 200 cents because there's $2, there's 100 cents in a dollar. But the way it works with unit conversions is that we look at the unit and we set up this equivalent relationship here, okay? And the way it is set up is so the dollars for the $2, right? That's the numerator. There's not, like, you could think of it as being written with a 1 underneath. But we set it up so the numerator dollars cancels with the denominator dollars down here. And that's why I have lines through them. Those cancel out. And what you're left with is in cents. So in your head, you're always doing dimensional analysis, right? You're doing it all the time. You just don't think of it that way. But knowing, like, systematically how these things set up will help you solve problems in the future. I'll skip this next one and I'll show you how this lays out. So as a problem solving strategy, when you're thinking about how to, in this particular instance, go from dollars to candy bars, right? What you have to do is have to think to yourself that, well, I have dollars, and I know the relationships between dollars and cents because there's 100 cents for a dollar, right? And then I know the number of cents there are per candy bar because there's 45 cents per candy bar. You write all that process out, and then you can use dimensional analysis to set the problem up efficiently so that you can check all your work in one place, do the calculation once, and get your answer. And the way that's done is shown here, right? It says $2, right, times, because the $2 is the quantity that's given, and then it gives a bunch of relationships. The 100 cents per dollar, so this will cancel like that, and then one candy bar for every 45 cents, so you can go like that, right? And then what you come up with is that you can buy 4.44 candy bars. Well, you can't buy 0.44 candy bars, but you could get 4. And if there were you and 3 friends, this is the scenario in the story. Yeah, each of you could have a candy bar. Okay, so you can read through that, but that's sort of the verbal description. And feel free to contact me through Canvas or ask for a Zoom meeting. There will be Zoom meeting, schedules throughout the week. So feel free to contact me at those times. I'll skip the units raised with power. Very much, I think, is self-explanatory. You can go back and read it. Okay. So the next thing I want to talk about is SI units and prefixes. And I'm going to skip all this and I'm going to go straight to the worksheet. This is exercise 1. And in exercise 1, I typed out the first example. Basically, what you're going to do is you're going to look up, right, what M means in an SI prefix. Now just Google it if you don't know what it means. It's fine. You will have to have all of these ones that are on this page. You'll all have to have them all memorized, quote unquote, right? Because this is an online class. If I were you, if I was me, I would write it on a sheet of paper and keep it as a reference so that you can look things up quickly. But this is 10 to the 6th, the name of that is mega. So like when you talk about megabytes, it's actually a unit that's close to 1,000,000 bytes. 10 to the 6th, right, is 1,000,000. The equivalent relationship, or the true relationship, some people like to call it, but the equivalent relationship is 1, in this case gram, 1 megagram is equal to 10 to the 6th grams. Now that can be used as a unit conversion between grams and megagrams. So how do you write this out, right? It's pretty simple, actually. M is on one side, which means the number, right, the exponent of 10 is on the other side. Now I show how you can use that in a calculation. There's the previous example up here. So go ahead and feel free to look back at that to see how I set that up. On the other hand, for example, if you look at this one, right, there's centi is over here, but the centi is on the right side. Whatever centi stands for has to be on the opposite side. So every time you set up one of these prefix conversions, what you have to make sure that you do is that you make sure that the prefix, right, is always on the opposite side of the number. Now, you may have learned some of these differently, and that's fine. But I would suggest you try to stick to this for now because it's part of a problem-solving method. And if you deviate from that, you might get yourself in a situation where you're confused about what you're supposed to do. Okay. Now, we're also supposed to be doing significant figures. But the reason problem 2 is here is to show you how you're supposed to set up all your problems. I don't want a bunch of one-step calculations. I want you to string it out, is what we say. We want you to start with the given number, right, and do the conversions until you get to the answer you're supposed to get to. Where people screw up with this is that they tend to not use the conversion factors in their book, and they just look up what is this equal to, and sure enough, Google will tell you how to do that, right? But again, this is a problem-solving method that we'll be using throughout the semester, so we really want you to stick to a set of conversion factors that we give to you or that are available to you in your book. So what we've done is if you go to look at table 1, those are all the conversion factors you're allowed to use. Okay, you can use these conversion factors, or you can use the prefixes that you look up here, but that's it. Don't go online and figure out what's a fun conversion factor I can use so that I only have to do one step. Okay, because when we start doing chemical problems, you can't do that. Okay, so we're trying to teach you the systematic way of setting up these problems. So use only those conversion factors. You'll get an answer that looks like this. Now, if I remember right, this is the answer your calculator tells you, right? But there's only 4 significant figures. So what you would actually do when you answer this question, you would say, put it in your calculator, 5, 6, 6, 6, 5, 6, 5. Or it might come out in scientific notation, right, inches. And then you would say, okay, 4 significant figures, that's here. So now that's going to equal 5.666 7, because it's going to round, times 10 to the 6th inches, like that. And then I want you to put a box around this answer, but this answer, the intermediate answer, has to be there so I know that you're doing your rounding correctly. Otherwise, there's really no way for me to check that you can do that intermediate step correctly. There's also no way for me to, sometimes there's small differences in your calculations, and then I'll give you credit for it anyways. But if I don't see that intermediate answer, I don't know how you got your final answer. Okay, so make sure you show all your work like it shows in problem 2. Right. Make sure you show the unrounded answer. You can mark the last significant figure and then round it and put a box around it. Okay. So that's really the stuff you need to know. Oops, sorry. That's really the stuff you need to know to get through this worksheet. Again, if you have any questions, feel free to follow up and ask for a Zoom session or text with me because I've sent you out my cell phone number. Okay.